So there are restrictions on square roots, and it's important to recognize that there are some inputs into square roots that we cannot accommodate. So for example, when we try to square root negative 25, okay, that's a problem because we cannot when we talk about negative 25 in terms of our models, well, first of all, it's very difficult to accommodate in our model of the inside is area and the square root represents side length because there's no such thing as an area of negative 25 meters squared. The other part is that when we think of it in terms of what gives us a negative number, well, we need a negative times positive to give us a negative 25. So we're trying to find a number that multiplies itself that gives us negative. Well, when we talk about the real number system, this can't be done. Okay, so what we'll say is that there is no number, I'm going to clarify this, no real number when multiplied by itself that gives us a negative. Okay, so positive times positive equals positive. Negative times negative gives us positive. Okay, so another way we can say this also is there is no, and I'm just going to write this as a separate point, but this is the same thing, no number squared is negative. Okay, so there's a bit of a problem there. Okay, so there are some restrictions to the domain of square roots. We cannot square root negative numbers. However, this one here, if we just follow the BEDMAS calculations, well, we can just say that negative 5 squared is positive 25, and the square root of positive 25 should be 5. Which is true. Okay, this is a fact true, because remember that this is a principal square root and it gives us a side length of a square when the area, although we started with negative 5, the area was positive 25 and we can make that into a positive, which is perfectly fine. Well, one thing to note is that this square root and squared didn't just undo itself and give us the original negative 5 that we started with. Okay, so there is this problems. It's a minor problem, but something that we should be aware of is that the square and square root are not perfect opposites of each other. Okay, and the other thing here as well, when we solve this, okay, if I were to just square root this and say, well, I'm going to square root both sides, we get x equals 5. Okay, well, this is not the solution to x squared equals 25 because 5 is not the only number squared that gives us 25. So this again highlights the issue that the square and square root are not perfect. They are not a perfect match when it comes to inverses or opposites. So when we solve something like this, when we square root both sides, we have to always remember that there is a plus minus involved. Okay, we have to accommodate the other part, the negative part, which does not necessarily show up in the principal square root. And this is a problem with the square root, is that it doesn't quite match the opposite of a parabola or square. So the solution to this is the answer to x squared equals 25 really is positive and negative 5. There's two answers. Because when I plug it back in, negative 5 squared equals 25, positive 5 squared equals 25. And so there is this issue when we undo squares, we have to remember that the square root only gives half the story, so we have to do plus minus square root. And this is the issue, this is why we have to be a little bit careful and understand that there is a slight difference in that the square root and the square are not perfect opposites of each other. Okay, so just something you need to be aware of, and just remember, how would you remember? Okay, so the one thing you can think of is, and you can come up with your own, but this is how I think of it, is that when we square the answer or calculation to square root always equals positive. Okay, and when we undo squares, or when we do the opposite of squares, so the power 2, we always get the positive and negative answer. Okay, there's always a plus minus when we undo squares. Okay, and we have to remember that that's something that we have to put in ourselves, because this issue that the square root and square are not exact perfect inverses of each other. And I'll give you one last thing, a visual, why we don't see them as inverses of each other, is because when we graph a parabola looks like that. Okay, and a perfect inverse is going to be the same graph, but it's going to be looking like that. It's a mirror image across this line here. All inverses have this relationship. The problem with square root is that the square root is only that part. But if we want to undo the square, we have to remember that there is not just the positive, which I've drawn in orange, but also the negative that we have to accommodate for. And that's why that we have to have this plus minus issue when we undo these squares. But going the opposite direction is not an issue. Okay, it's going from squares to square roots. If I'm solving a square, this is the situation here, solving a square by using a square root, we have to use plus minus.